Hello, this is my brief tutorial about how to use PCG together with Niagara Data Channel Interface. It's a recently added feature, still in experimental stage, so I couldn't find any tutorial video. I figured out how to use this feature with my own trial and error, and I want to share what I've found. So all these grasses are Niagara particles generated at runtime and cleaned at runtime using PCG and NDC. You can see that the grasses are generated as I move near to the mountain, and they are disappearing as I move further away from the mountain. I'm rendering the grasses using Bezier curve, so it's a curve controlled by Bezier points. So the motion I'm simulating is not the grass itself, it's actually these green bars here. I'm assuming that there are pivot joints, joints with rotations, and these joints are assumed to have some elasticity, so if I bend them, they would try to go back to their original static positions. And this is how grasses are rendered in Ghost of Tsushima. This simulation is my own implementation of a Ghost of Tsushima grass with my motion based on some physics. I am using what's called articulated body algorithm to generate the motions, so it's dynamics-based motion, and that's the reason why I'm using Niagara. I cannot just use a static mesh spawner because each grass instance has its own angular velocity and angular displacement. Those data need to be kept in GPU and updated every frame, and it's done using Niagara. Oh, and in this tutorial, I'm assuming that you already know about NDC. You have at least watched the NDC tutorial video made by Epic Games, and you know about PCG runtime generation, and PCG hierarchical grid. So this is my PCG blueprint. It's using 4 grid sizes. They're sampling at different rates. After sampling the points get processed, and some points data are written to Niagara Data Channel. You can write data to Niagara Data Channel by using this node here. You can use this node by adding a experimental plugin. This is the plugin, Procedural Content Generation Framework, Niagara Interop. By adding this plugin, you can use this node here, and you can set which point data you want to write to NDC. And there's one error I found in this plugin. You cannot write integer data. If you try to write integer data, the engine gets crashed. I'm using 4 different Niagara data channel with 4 different Niagara system. So if you look at my NDC interface, they have different Niagara system assigned to them and different extent size. This extent size matches with the grid size. For 400 grid, I am setting this to 200. It's 200, but it goes in both positive direction and negative direction of the XYZ axis, so the size becomes 400. So the grid size and the extent size is the same. So for each 400 grid, there is only one Niagara emitter instance appear in the grid. So one Niagara emitter instance is covering one 400 grid. And for this channel, there is one emitter instance created by this channel that covers one 800 size grid. So what I'm doing is the emitter instance to have the matching extent size with the grid size, and only one emitter instance for per grid in each grid size. I'm disabling these nodes here and only enabling this. Let's see what happens. So you see that as I move my camera location, only near grasses appear, and grasses disappear as I move far away from the grids. When PCG is writing data to NDC, it's writing the whole data within one single 400 grid, but what you're seeing is some gradual appearance of the particles. This is because I'm resizing particles based on the camera distance. I'm making them smaller when they are farther away than certain distance. So if I remove the feature, so there's one single Niagara emitter here and 4 different Niagara system for each grid size. So I'm turning off the mesh resizing feature based on camera distance. I'm using this value to resize the mesh. And now you can see the grasses within the same grid appear simultaneously. So let's see what's really Niagara emitter to generate the grass particles. I follow the same way as shown in the NDC tutorial made by Epic Games. I just added some additional process. Well, let's see. So this is exactly the same as the tutorial. One thing I've done additionally is recording the last spawn time. So I checked the number of data in the channel, and if that's greater than 0, so if there's any data in the channel, I update this emitter attribute to current engine time. And if there isn't any data from the channel, then it just stays the same value. So that's for the emitter update stage. And for the particle spawn stage, I'm also doing the similar thing. I'm following the tutorial to read the data from NDC channel, but I'm recording the particles spawning time. So there are only 2 things that I've done differently from the tutorial video: recording the spawn time of the particle and recording the last particle spawn time in the emitter instance. When you are using static mesh spawner, PCG would do the cleanup and generation for you automatically. But when you are using this write to NDC data channel, it just writes data to NDC. There isn't any particle cleanup done from PCG. What happens is that a grid enters within the generation radius. PCG writes that grid point data to NDC and does not write the same data again until the grid becomes farther away than the cleanup radius. And then if the grid enters within the generation radius again, then PCG writes the same data again. So if I turn off any particle killing modules, I'm changing this sampling rate so this could be more visible. The grasses are generated as I move my camera location. And if I move back to the path, you can see there are some duplicate particles at the same position. When I faced this issue, the first solution I thought about was killing particles based on the camera distance. And that's what actually I'm doing with my current emitter. So in one sketchpad module, I'm measuring the distance between the camera and the grid, not the distance between the particle and the camera, the distance between the camera and the grid where the particle belongs to. It's calculated with this code here. I get the minimum x value, y value, and maximum x, y value for the grid. And then calculate the length between the grid and the camera position. Now I'm not using the z value because the current PCG I'm using is only making grid with the xy plane. So this module is killing the particles if the the distance is greater than this b value here. So in the system attributes, I set the PCG generation radius and PCG grid size with the cleanup multiplier. This module first adds the PCG generation radius and the grid size and multiply it by the cleanup multiplier. And if that value is less than this a value here, particles is killed. So if I only turn this on, then there are less duplicates, but there are still some duplicates. Yeah, these are the duplicate particles. There are duplicates still because the camera distance calculation and killing is done in GPU, but PCG cleanup is done in CPU. So there is a gap between those two processes. There isn't any perfect sync. PCG cleanup process can also be cancelled if you move between the generation radius and cleanup radius quickly. So cleaning up particles based on the camera distance within the Niagara is not enough. I'm killing particles by comparing the spawning time recorded in the last particle spawning time recorded in emitter attribute and particles spawn time. This would be the last time PCG has sent the point data from the grid covered by this emitter instance. And you compare this value with the particle spawn time. Well, particle spawn time added by 1 second. Because particles are just created simultaneously, they do not have the exact same value as this one. So I'm just adding 1 second here. If the particle spawn time plus 1 is earlier than this last particle spawn time, the module is killing the particle. So this would not work properly if your character had some teleportation ability or just moves really fast. In that case, I don't know, you should make your own method to kill the particles. So after turning on both features, I can remove all duplicate particles. Some of you may notice that I really don't need this one to remove duplicate particles. This one alone is enough, but the problem with this one is that this one is a lazy killing. It kills a particle only when there is a new grid point data sent from the PCG. But this one kills particle instantly if the particle becomes too far away and does not need to get rendered anymore. So I'm using both methods. This one for killing particles instantly, and this one for lazy killing leftover duplicate. So by turning on both modules, there wouldn't be any duplicate particles anymore. So everything I did additionally, recording the last particle spawn time to emitter and particle spawn time for each particle. It's all for killing particles. So if you have a Niagara with particles that have lifespans, then you really don't need these additional processes. You don't have to record the particle spawn time and last spawn time of the particle to emitter, and you don't even need to use different Niagara data channel and Niagara system for different grid size. You can just use a single Niagara data channel with a single Niagara system. So that's all for my tutorial. I think this write to NDC from PCG is a really strong feature. It allows me to simulate these many classes based on dynamics motion. I hope this tutorial has given you some help. Thank you for watching. Bye bye.